Okay, so guys, now we are having a proof question which says that y is equal to, this is the given, okay, and we have to prove this thing. To prove, okay, so the question says that y is actually equal to root tan x plus root tan x plus root tan x, and this thing continues until infinity, okay. But remember, this is the parent square root, okay. We are having square plus square plus square plus square, and this thing is continuing. So you understood what is the square pattern over here, the square root pattern over here. It says that you have to find 2y minus 1 divided by dx sec square x. Clearly we are seeing that we have dy by dx, so we have to put in the differential at some point in the equation, okay. Now if I just take out this equation, so we have y equals this thing continues till infinity, okay. Now if I apply a differential over here at this point, it will actually be impossible to solve this question. You know why? Because we have infinity over here. If I just apply infinity to a differential, it will give us an error, okay. So how can I do this? First of all, let me just square these terms, okay. By squaring, I will be able to remove this parent square root, okay. Let me just square it. So y squared, let me just square it over here. So y squared, and this thing would be squared. This parent square root would be cancelled, the big one. We are left with tan x, but still these square roots are not cancelled, which are present inside the parent square root, okay. So let me just first of all, just for our clarification, let me just number these, label these square roots. So this would be my first square root, this would be my second square root, and this would be my third square root. Then plus we have, this thing is still over there, so we have tangent x plus square root tangent x plus square root, okay. So you see how this pattern is continuing till infinity. We have y squared. Now we know that this entire thing is actually equal to something, and that is y, because we know that our original, the given thing for this question was y. And what was the value of y? It was root tan x plus another root tan x plus another root tan x, right? So we can actually replace this entire thing by y, because this was the actual given thing. This was actually the part of the question. So we can write it as tangent x plus y and then y squared. Now this the equation looks much more simple. We can actually proceed it by applying the differentials and applying different techniques for finding the thing which we have to prove. So now let's just apply the differentials on both sides of the equation, because at the end of the day you would have to apply the differential, because the thing which we have to prove, we have dy by dx, okay. So let's just apply the differentials. Now remember, the differential would be with respect to x, because we have x over here. Y square would be equal to d by dx plus d by dx y. So this is the power, so we are going to separate it, 2y. Then the derivative of the angle is y, so d by dx y. Then the derivative of tan x is actually equal to secant square x, so we have secant squared x. And if you do not know about these quantities, what is the derivative of sine x, cos x, cosecant x, secant x, you can check out the PDF which I have uploaded on the Google Drive containing all of these values, okay. So then we have dy by dx, okay. So we are approximately close towards this question, because you know we have 2y minus 1 dy by dx secant square x, and actually we have solved the question. You know why? We can put the like terms on one side of the equation and the unlike terms on the other side of the equation. So I have 2y by dx, 2y dy by dx and dy by dx over here, so I can move this dy by dx toward the opposite side of the equation. So I will have 2y dy by dx minus dy by dx is equal to secant squared x. So if these are like terms, we can actually take them out as common. So d by dx would be 2y minus 1 is equal to secant square x, okay. 2y was present over here, this was cancelled by this dy by dx, so we are left with 1. Now yeah, so that was pretty much it. We have, this was to prove, this was the thing which we had to find, okay. So yeah, this is the proof of this question.